This is the Chapter 8, Segment 3 outline. We're going to begin by how the dorsal column carries somatosensory information from the skin to the brain. The touch receptors such as the Pascinian corpuscles, Merkel's discs, and Meissner's corpuscles send their axons to the spinal cord, where they enter the dorsal horn and turn upward, traveling to the brain along the spinal cord dorsal column of the white matter, which is also why this is called the dorsal column system. The axons will go all the way up to the brainstem, where they synapse on the neurons of the dorsal column nuclei in the medulla. The axons of the medullary neurons then cross the midline to the opposite side of the and descend to a group of nuclei of the thalamus. Outputs of the thalamus are directed to the primary somatosensory cortex. The skin can be divided into bands corresponding to the spinal nerves that carry the axons from different regions. The dermatome is a region of skin innervated by a particular spinal nerve. Plasticity and cortical maps. Cortical maps can change with experience. Professional musicians who play stringed instruments have expanded cortical representations of their left fingers, presumably because they have been using these fingers to depress the strings for precisely the right notes. Pain. Pain is described as an unpleasant but adaptive experience. Pain is an unpleasant sensory or emotional experience associated with actual or potential tissue damage or described in terms of such damage. Congenital insensitivity to pain. The condition of being born without the ability to perceive pain. Extensive scarring, they die young of injuries. People who display pain insensitivity can discriminate between touch of the point or head of a pin, but they experience no pain when pricked with the point. 3 ways pain helps us. Short-lasting pain causes us to withdraw from the source, often reflectively, thus preventing further damage. 2. Long-lasting pain promotes behaviors such as sleep, inactivity, grooming, feeding, drinking, and promote further recuperation. Number 3. The expression of pain serves as a social signal to other animals. For example, screeching after a painful stimulus signals a potential harm to genetically related individuals and elicits caregiving behavior from them, such as grooming, defending, and feeding. Human pain can be measured. Learning, experience, emotion, and culture all affect the perception of pain in striking ways. The terms mild and intense are inadequate to describe the pain that is distinctive to a particular injury or disease. McGill's 3 aspects of pain: the sensory discriminative quality, which is throbbing, gnawing, shooting; the motivational affective, which is emotional, which is quality, tiring, sickening, fearful; and overall cognitive evaluative quality, no pain, mild, excruciating. Patients are asked to select a set of words that describe their pain. The peripheral nervous system and the central nervous system pathways that mediate pain. First, the peripheral. The initial stimulus for pain is a destruction or injury of tissue adjacent to the certain nerve fibers. The damaged tissue releases chemicals that activate pain fibers in the skin. Chemical mediators of pain: neuropeptides, serotonin, histamine, various protein metabolizing enzymes, and a group of hormones. Peripheral receptors and nerve fibers that are specialized to respond to pain are nociceptors. The best evidence for specialized pain fibers in the periphery came from studies of capsaicin, the chemical that makes chili peppers spicy hot. The receptor responds to sudden increases in temperature. The receptor was cloned and found out to be a member of the family of proteins called transient receptor potential ion channels. They named the capsaicin receptor transient receptor potential vanillite type 1 or vanillite receptor 1 because the crucial component of capsaicin molecule is a chemical known as vanilloid. So the reason why chili peppers are so hot is because the capsaicin in the peppers activates TRPV1 receptors in the body that normally detect noxious heat. Capsaicin molecules have a perfect shape to bind the TRPV1 and open its ion channel, which is normally opened by heat. Now I'm going to go TRP3 versus TRPV1. TRPV3 detects even higher temperatures normally than TRPV1 does. TRPV3 does not respond to capsaicin and these receptors are found on their fibers larger than those carrying TRPV1. Large axons conduct exon potentials more rapidly than small axons do. TRPV3 receptors are found on relatively large axons as fibers, long diameter and myelinated axons. They report to the spinal cord very quickly. TRP1, on the other hand, is thin and unmyelinated axon fibers called C fibers. C fibers conduct slowly, and TRPV1 adapts slowly, providing the second wave of pain, a dull, lasting ache. And one more thing we'll go over is the cool menthol receptor 1. It's a member of the TRP family, also known as TRPM8, but responds to cool temperatures and is found on small C fibers, so it transmits information about cool temperatures rather slowly. Spices add so much to our experience of food because they stimulate these various receptors in our mouth. And that concludes my YouTube presentation on Chapter 8, Segment 3.